In this video we're going to take a look at some of the web challenges from the picoMini CTF, which is run by redpwn this weekend. I had a couple of comments about the terminal font size, so I've increased it from 12 to 16 and increased the font size in text editors as well, and I'll make an effort to zoom in on things whenever I'm editing videos as well. So let me know how that goes. I'll also export a higher volume because I had some comments about volume issues as well. So hopefully that'll sort things out. If there's any problems, let me know. And with that out of the way, let's start off with the login challenge. So the description says, my dog sitter's brother made this website but I can't get in, can you help? We don't have any source code or anything, we've just got this URL to visit, so we check it out and quickly see that we have a basic login form. So before even looking at the source code, we might just want to send off an apostrophe to see if we get any errors, which we don't. So let's take a look at the source. And there's not too much here. We've got a basic login form and we have our CSS and JavaScript, so we probably want to go and take a look at the JavaScript since there's not much else to check out, and it's not formatted very nicely. So let's go back to our main page and just hit F12 to bring up the developer tools, and we can go in here to the debugger and just select index.js, and this will give us some syntax highlighting so we can see, so we can read the code a little bit easier. We can also then enable pretty print source down at the bottom, and this will make it easier still to view the code. So the best way to approach this is to reverse this from our end goal. We know that we want to print the flag, and we can see right here that if we get the correct password, it's going to print the flag, and it's going to call this function atob or atob with the t.p. So let's have a look first of all. Let's just go and have a look for JavaScript atob and have a look at the documentation, and we'll see that this will decode a base64 encoded string. So we can use atob or the reverse of that to encode and decode base64 encoded strings. So let's go back to our code again, and if we take a look here, we'll see that we have our base64. So this is going to encode in base64 and this is going to decode in base64. So let's have a look and try and trace back what it's decoding. We have this t.p, and if we go here, we'll see that we have this object t, which is initially empty, there's nothing in there, but we have this constant object r. So at the beginning we have r, which is set up to have r.u is going to be the username which is entered here, and r.p is going to be the password which is entered here. We're then going to assign a new empty object, this t, which we're interested in, and it's going to loop through the constants in r and assign those to t. So it's essentially copying over the username and the password from r over to t, but it's not just copying over the raw values. It is first base64 encoding the value, and then it's replacing any equals that it finds in the string, and then the results will be in t. So we'll have this t.p, which we have right here, and then we'll also have t.u as well, which is right here. So then it's just doing the comparison between these two strings. So whenever I actually solved this challenge, I actually just went straight to base64 decoding these strings. I didn't actually really read the code, just grabbed the strings and decoded them. Let's take a copy of this and go over to our decoder, or let's go over to hackverter here. I've actually still got something already in there, but let's do decode base64, and if we paste that in, we'll get ADM, which doesn't actually look right. So let's try it again, base64 decode URL. We enter that in and we get admin. So what was the difference there? Well, let's go back and do base64 again and just paste that in. We have ADM. Let's insert a couple of equals, or just one equals, and that got us our admin. So the issue was that we saw here it was stripping equals out, and that's the padding that was required there to decode the full string. So you can either use base64 the URL mode, or you can insert enough equals to pad it out. So we've got the username there. Let's go and do the same thing with the password as well. Just paste that in there and we'll see there's our password. So we could take these right now and we could go and insert this as admin and our password. We submit those and we get correct password, your flag is, and it's given us our flag. The next challenge is called CAS, or cowsay-as-a-service, and we have a JavaScript file to download, but we're just going to take a look at the site first of all and test out the functionality. And we'll see that we're told to visit the following URL, so we need to insert cowsay here and then a message. So I'm just going to say hi, and you'll see we get this little picture of a cow saying hi. We can change the message and say something else. So we might want to go and investigate what is this cowsay tool, and we'll see there's a program that generates ASCII pictures of a cow with a message. So it's just a Linux binary which is running, and you can install it just with sudo apt-get. So the first thing we want to do here is try some command injection, right? Because this is running as a service. So if this is just running on the command line somewhere, we might, and they're taking our input here as the parameter, we might be able to inject something else in here. So let's say we want to end that current command with a semicolon, and then let's say we want to list what's in the current directory. And pretty easily we get our command injection. So we're able to list all the files, which means that we can also say we want to cat falg.txt, and that will give us the flag. There are many different ways we could do command injection as well, so we might want to try and just insert in some different characters here. We can use a pipe, we might be able to inject a bash command here as well. So you can see there's various different ways that we could do that. Let's also go and take a look at the source code, just seen as we didn't need it to solve the challenge, but we might as well go and take a look at it. And we'll see then that we have, whenever we make a GET request to the cowsay directory, it will take the message and it will call this binary in user games cowsay. It'll call that with our message, and then it'll return the response. So there's no sanitization here happening. The input that the user provides is just being taken as raw input. We're not checking for any characters which could allow command injection, and we're calling this dangerous exec function, which is dangerous whenever you're taking a user input. So we could go and test this out as well locally and try cowsay hi. You can see we get a picture of a cow. If we do some injection here and add who am I, then you'll see that it's appended the who am I command to the cowsay hi command. The last challenge we're going to take a look at is called pastebin-1, and as you can see I didn't solve this challenge during a competition, unfortunately, but I spent quite a lot of time working on it, so I wanted to come back after seeing some other write-ups and walk through it, because although most of the challenges will be put on the Pico Gym, I think pastebin-1, pastebin-2 and safe scripts won't be. So I'll run through pastebin-1, and maybe Notepad will just wait and check out on Pico Gym at some point. I'm not able to open this up and have a look at the description, but essentially we were given two links. There was one to this pastebin admin bot, and we can see here that we can paste in a link and the admin is going to visit the URL. Our goal was simply to steal the cookie, so we need to provide some URL here which is going to allow us to steal the cookie from the admin. And then we also have a pastebin, like a little fake pastebin site here, so we can enter in something here and it'll essentially just send that as a query, and that'll appear on the page. Apart from that, we were given access to some source code, so let's go and take a look at that. So anybody who competed in the Hack the Box Cyber Apocalypse CTF a couple of weeks ago might be thinking this challenge looks a little bit familiar, because there was a challenge in there where we had a bot and we needed to provide a URL to steal the cookie. So it's quite a similar challenge, both XSS based, but before we jump into the specifics of the vulnerabilities here, let's just step through the general code. We have a HTTP server which is being created here, and we have to make a GET request. If we make a POST request or something, we're just going to get a 405 error. If we do make a GET request, it's going to split our URL into the path name and the query. So if we submit this URL here, that will be broken up into these two parts, and then it's going to take anything that we provide as a paste query. It's going to assign that into a variable which we can see will be used down here. But in order to get down here, we have to get past this part. So this part's essentially saying if we try to access any path except the home directory, then we're going to get this unknown path. So you can see the send message being created here with a 302 header. So it's going to write a 302 header to redirect the location, and then we have the message which is being encoded there. So let's just test it out just to see what that looks like. If we go back here, let's just load the page normally first of all. You can see that's just a GET request, 200 response. But if we try and visit now something other than the home directory, you'll see that we get our 200, but then we get this 302. And the 302 is the header, which is the location headers redirecting us to this unknown path. And you can see that we have that right there, and we also have that showing on the page as well. So this is good to know. It means we know we have somewhere that we can reflect data to, using a DOM-based reflection. But again, let's go back to the code before we look into that. So we make it past that part, and next it'll check to see whether we provided the paste query. So if we didn't provide the paste query, if there wasn't a paste query provided, it's going to load page new, which you can see this is the page, this is the HTML we have right here, and it's going to load it with the content security policy header set, which is set to, well, you can see we have a couple of options set here, but let's just move on for now. And if we did provide the paste query, then we're going to get the same result. Basically, we get the same stuff, but the headers for the content security policy are a little bit different, and it'll just load our paste rather than this page new. So let's go and test that out again. We say hello here and submit it, and we get back hello, and we can see that's so that's basically what it's loading as the HTML. So the first thing we want to do is try and find a way to trigger XSS. The obvious option would be the paste thing here, since this is called pastebin, but if we try to provide something like, let's just try and put in a standard script to test this out, and if we submit that, let's view the source. So it all looks good, but it doesn't execute. In fact, let's load this again with the developer tools open. And if we load it with the developer tools open, we'll see that the problem is the content security policy is blocking the loading of resources. So let's go and have a look at the content security policy. If we go and have a look at some of the documentation here, this is for the script src. So essentially this is going to define what can and can't load. So we have a default catch-all here, which will basically say don't load anything, don't load any iframes, don't load any images, don't load any scripts, don't load them from anywhere. And this is the default, but anything that we specify after here will be used as precedent. So here we're basically saying you don't load anything at all except scripts which are from self, so from the same domain, or have this SHA-256 hash. And down here it's just saying nothing, don't load anything. So there's nothing at all that we're going to be able to do to paste something into this site here and ensure that it's executed. If we go back and look at this section, though, we do have a looser content security policy whereby we can load scripts from self, or if they have this SHA-256 hash. So if we go back to documentation again here and have a look here, we can see that self means we'll be able to load scripts from, well, in this case, because it's a script src, this could be image src or frame src or something like that, just defining what type of content can be loaded from where. And in this case then we'll be able to load scripts from ourselves, from the protected document that's being served, including the same URL, scheme and port number. But the problem is that is not for the paste, so if that's only if we don't provide a paste query, which means we can't just put in a script here and send that off. So is there somewhere else on the page that we might be able to inject a script into? Well, we might remember from the beginning that if we are able to generate an error, we reflect that to the screen, didn't we? So if we put in here new, we got this unknown path, so this error could be something else then. So we could say hello, and you can see that's been reflected there. So what we might think here then is there some way that we can inject a script in this way? Let's try and do the same thing as we did earlier. And we don't see anything there, which is a good sign, but you'll see here we get this page setting blocked loading of a resource at inline script src. So the problem is, although we're able to load scripts from self, we're still not able to use inline scripts. In order to do that, we would need this unsafe inline directive to have been included, and unfortunately it wasn't. So even if we go back here and actually have a look, let's have a look with the inspector, and we'll see this div ID error, and it's actually written out our script, it's just not executing it. So now I think it's a good time to bring up some documentation. This is the Portswigger Web Security Academy, which has some great labs and documentation on cross-site scripting and other vulnerabilities. So here we have some information about DOM-based cross-site scripting, and I'll not go through too much of this. I advise you to check it out yourself if you're interested in trying to learn this stuff. But some key points. DOM-based vulnerabilities arise when a website contains JavaScript that takes an attacker controllable value known as a source and passes it to a dangerous function known as a sink. So we have sources and sinks, and we have some examples of sources here like location.search, and sinks then like eval or document.body.inner.html. So what's our source and what's our sink here? Well, if we have a look at the code, we can see here that the value that we control is this location.hash.slice1, and it's been assigned here to the error.inner.html. So let's remind ourselves again. We can see here something quite similar, document.body.inner.html, and this is dangerous because it allows an attacker to inject malicious HTML and execute arbitrary JavaScript. So we're able to do that providing that we have control of a source, and in this case it was the location. So let's go back here, and if we actually go into our console and just do location.hash.slice, we can see that that is the script, everything that we have after the hash here. So we know that this is a DOM-based XSS vulnerability, but it's just made a little bit more complicated for us in this case because we have the content security policy issue to bypass. So when we're looking to test out content security policies as well and see if they're secure, we can use some online evaluators. This one here, CSP Evaluator with google.com. And let's take a copy then of our URL and supply it to the evaluator, and this will let us know what's set and what the problems with that might be. So it's telling us that the default SRC is good. That means everything will be denied unless it's specifically allowed in some other directives. But the script SRC here, you can see that we have some hints in it, and if we drill down into the info, we have the self option, which it says is a possible medium severity finding. So self can be problematic if you host JSONP, Angular, or user uploaded files. And we also see here that we could include this require trusted types for to help reduce or stop DOM-based XSS. So I'll open up another link here with some bypasses regarding JSONP, Angular, and user uploaded files. I did find this whenever I was working through the challenge, but didn't try all of the options, and as luck would have it, the final option is the one that we need. So before I go back to that, let's just go back to the basics. So if we're able to include scripts from self, my initial kind of thinking of this would be, well, we can't provide our script in here. If we try to provide our script, we know that it's going to let me actually just send this off again. We know that if we provide the script, our inline script is going to be blocked. But if we were to say just provide the contents of the script here, alert 0, and submit that, and then use this as the URL so we can load this as a script. So in here we know that we need to provide something after the hash. So in here I kind of hoped that we might be able to just say script src equals, and then we provide in the URL of that script. But this doesn't work, unfortunately. Let's just try it out anyway. So we tried it out, we don't see anything, but if we go and have a look here at the error, we can see that it does have the script src in there, but it doesn't actually execute the script. So if we return to the CSP bypass article here, we'll see that the tip was, in DOM-based injection scenarios, a script used for CSP bypass might not load, as it didn't for us, so we can use a follow-in to achieve execution. So if we take a copy of this, let's go back to our paste bin, and essentially we're going to want to replace our script source with this. So let's take our paste bin URL out of there and just replace the URL with that. Remove the remaining code, and hopefully if we load this we'll see an alert pop up, which we do. So we've got successful execution. So we know that if we send this to the admin, if we paste that into the admin bot, then they're going to get that pop up on the screen, but obviously that's not much good to us. We want to retrieve their cookie, so we're going to need to make a callback to do that. So there's a few different ways we can do that. One of them is to use request bin. There's probably some similar services here. You can create them private or public. It doesn't really matter in this case. And then we can just take a copy of the URL, and let's try and visit the URL first of all. If we try and visit the URL, we can see then that we get this GET request, and that allows us to analyze whatever's sent. So if we were to send something off here and say password equals this is secret, we send that off, and then we go back to our request bin and we see that that's been sent. So we want to essentially do the exact same thing here. We want to provide this URL and we want to open it here. So what I would normally do is set like the document.location here, but in this case we're going to want to, let's use window.open, because I had some problems using equals and plus signs due to it obviously being in a URL. So we could do some kind of URL encoding, but I saw this on the solution which I used to complete it in the end, so we'll just keep with that. So rather than using plus document.cookie here, we can use .concat and then provide document.cookie, and hopefully that'll work for us. Let's just try and do this locally first of all. Let me show that pop up so that we can get the cookie. Okay, there was no cookie anyway in this case. I just realized that we don't have a cookie set. So alright, I'm just gonna, it looks like that sent that off okay anyway, so I'm just gonna take this URL, this whole URL, and we'll send this to the admin bot and see if we submit it, does it make a request to our server? Hopefully it does. And there you can see that quite quickly we got back the flag, which is content security policy is cool. So I hope you've enjoyed this challenge. Let me actually just bring up the write-up, because I didn't get this solved. They kept the challenge up for a while. It's not going to be on Pico Gym, but I just wanted to go through it while it's still up here. But this is the write-up that I used to solve it, and I noticed there's quite a few other write-ups from the same CTF and from other CTFs here, so well worth checking out this repo if you want to keep up with some CTF write-ups. And I hope you've enjoyed the video. If you have any questions or comments, leave them down below. Thanks.